Hey everyone, and welcome to this explainer. Today, we're taking a documentary-style look at a massive, completely invisible environmental challenge that's literally hiding right in plain sight. Think about it. Every single day, fleets of garbage trucks haul away the remnants of our modern lives, right? And they just bury it all in these massive sites on the outskirts of town. But the story of our waste doesn't actually end when the garbage truck pulls away. In fact, that's exactly where an enormous, unseen threat to our climate begins. We're going to dive into the hidden world of waste management. Specifically, we're looking at the staggering greenhouse gas emissions it generates, the really intense regulatory pressures it's facing right now, and the brilliant, downright fascinating engineering being used to turn this invisible giant from a huge liability into a super valuable asset. Let's get into it.
So right off the bat, I want you to completely rethink how you view a municipal landfill. Most of us, we tend to think of landfills as these inert, quiet graveyards for all our discarded stuff. But they really aren't. They are highly active biological entities. Deep down beneath the surface, under literally millions of tons of compressed debris, a massive chemical transformation is constantly taking place. So I have to ask, what actually happens when our trash breathes?
Well, as all that organic waste decomposes in the dark, without any oxygen, which is a process called anaerobic decomposition, it produces something called landfill gas. And here's the kicker. This gas is heavily composed of methane. That methane makes landfills a highly significant anthropogenic, meaning human-caused, contributor to global greenhouse gas emissions. You can basically picture the landfill exhaling this highly potent gas directly into our atmosphere 24 hours a day, 7 days a week. It never stops.
Okay, so how do we actually measure this invisible threat? Well, sustainability accountants use a universal yardstick, Scope 1 emissions. If you look at the Greenhouse Gas Protocol, these direct emissions from landfills are classified firmly as Scope 1. Now that includes the 7 major greenhouse gases, but in the waste management world, we're primarily talking about carbon dioxide and methane. For accounting purposes, all of this gets consolidated and measured in metric tons of CO2 equivalent, using their global warming potential values. That gives us a really clear quantitative way to measure the true, massive scale of the emissions escaping from these sites.
All right, moving into Section 1, the regulatory net. This is all about caging that invisible giant.
Because landfills are such colossal sources of methane, global governments and regulators are definitely not just sitting on the sidelines. They are actively throwing a massive, restrictive regulatory net over the entire industry to get this under control. And we're not talking about voluntary guidelines here. We're seeing incredibly strict command and control approaches and market-based mechanisms. Think about things like the California Cap-and-Trade program, the European Union Emissions Trading Scheme, and the Quebec Cap-and-Trade system. These are rigid emissions limiting regulations paired with mandatory reporting rules. Waste management companies today have to meticulously calculate the exact percentage of their global Scope 1 emissions that fall under these specific programs.
And why does this matter? Well, it matters deeply to business leaders, to investors, and honestly, to you and me. Excessive greenhouse gas emissions pose a severe regulatory risk. If a waste management entity fails to control its landfill gas, it faces a very direct, very real threat to its bottom line. We're talking skyrocketing operational costs and forced capital expenditures just to fix the problem. But even more critically than that, poor performance on this issue can severely impact a company's ability to secure new facility permits or even renew their existing ones. And think about it. If you can't get a permit to run a landfill, you lose your license to operate entirely. Game over.
Okay, let's pivot to Section 2, taming the gas. This is where we go from an environmental threat to an actual energy source.
This is where our story shifts, right? It goes from this looming environmental and regulatory nightmare into a really fascinating tale of technological optimism. The industry hasn't just given up, they've developed incredibly sophisticated engineering solutions to actually capture this gas. Let's walk through the life cycle step by step. Step 1 is generation. That's the unavoidable result of the anaerobic decomposition we talked about earlier. Step 2 is collection. Now, this requires huge capital investment to install these incredibly complex networks of pipes and vacuums deep down into the landfill to suck up the gas before it can escape. Step 3 is flaring, and Step 4 is energy recovery. And those final 2 steps, that is where the magic really happens, turning a massive liability into a controlled substance or even a highly valuable product.
So, let's talk about flaring. I know, setting things on fire sounds counterintuitive when we're talking about the environment, but flaring is often the crucial first line of defense. We deliberately set this gas on fire because by combusting the raw methane using an open flame, either using ambient air or blown air, companies drastically reduce the overall toxicity and the climate potency of the emissions long before they ever hit the atmosphere. It's an absolutely vital harm reduction strategy.
Now, under standardized sustainability metrics, waste entities can't just wave their hands and say they handled it. They have to rigorously report the total amount of landfill gas they generate, which is measured in MMBTU, or millions of British thermal units. But they don't just report that one big total, they have to slice it up. They disclose exactly what percentage was simply flared to reduce harm, and ideally what percentage was successfully captured and actually used for energy.
And that percentage used for energy, that's the ultimate prize. That's the holy grail here. Instead of just burning the gas away into nothing, that captured methane can actually be combusted to fuel turbines, power on-site engines, or it can even be processed and piped out for off-site energy use. This is huge because it allows waste management entities to generate entirely new revenue streams by selling natural gas and energy. Plus, on top of that, they can significantly reduce their own operating expenses by using this processed gas to power their own garbage trucks and facilities. It's a total win-win.
And the financial markets? They take this incredibly seriously. Under the SASB sustainability accounting standards, which global investors rely on heavily, tracking gross global Scope 1 emissions, tracking the percentage covered by regulations, and providing the exact breakdown of landfill gas generated, flared, and used for energy, those are mandatory quantitative metrics. It proves that caging this invisible giant isn't just about good PR anymore. It's about hard, audited financial data.
Which brings us to Section 3, the grand trade-off, balancing Scope 1 versus life cycle emissions.
This introduces a genuinely fascinating strategic dilemma. Imagine you're running one of these waste management companies. You aren't just managing the trash sitting right in front of you, you're actually managing time. You have to balance immediate, direct emissions against long-term planetary impacts. For example, one way to avoid methane from landfills entirely is to use waste-to-energy, or WTE facilities. These places literally incinerate the waste to generate power. Now, operating a WTE facility creates an immediate, massive spike in your short-term Scope 1 emissions right now, today, because you are actively burning the waste. But over the long term, WTE actually decreases the total life cycle emissions of that waste. Why? Because it completely prevents the future methane generation that would have slowly leaked out if it sat in a landfill for decades. Plus, it displaces the need to burn fossil fuels to create that exact same amount of electricity.
So corporate strategy here requires a really delicate balancing act. Companies have to explicitly discuss how they are evaluating these trade-offs within their broader business strategy and their capital expenditure plans. Do they prioritize taking a hit on their short-term Scope 1 accounting to secure a massive long-term environmental benefit for the planet? It's a really profound strategic question about how we, as a society, handle the end of life for all our materials.
To prove to regulators and investors that they are actually navigating this trade-off successfully, these entities must lay out crystal-clear plans. They set very specific emission reduction targets, and they have to detail whether those are absolute reductions or intensity-based metrics. They establish a firm baseline years so everyone can compare the progress. They track their percentage reductions over clearly defined timelines, and they publicly disclose the exact operational mechanisms and financial investments they're going to use to hit those targets. It is a highly structured, scrutinized roadmap to a cleaner future.
So, we've seen how the invisible giant of landfill methane presents a massive climate threat and a really severe regulatory risk. But we've also seen the incredible, almost sci-fi engineering being used to capture, control, and monetize that very same gas. It kind of totally changes how you look at a garbage truck, doesn't it? The next time you toss something in the trash, I want you to remember the immense, unseen infrastructure waiting to receive it. So I leave you with this. When you throw something away, is it really the end of the line, or is it just the beginning of a brand new power source? Thanks so much for joining me on this explainer. See you next time.